So in this video, we're going to look at how questions can look really similar but be really different. In particular, in mechanics, how the type of acceleration can be spotted in a question. So here we go. The velocity, we've got 5I minus 2j. Now notice that there are no t values in here. So it means that this is the velocity always. This means we have a no acceleration situation. And if there's no acceleration, well, there's no sort of suvat. Well, there's no need to use suvat is what I suppose I'm trying to say. And there's generally no need as well to do any calculus. So what are we going to do then? Well, what we're going to do is we're essentially going to use our distance equals speed times time. However, in reality, how it tends to come up really at A level is this idea that where you are is where you started plus where you're going for how long. Okay, I've heard this referred to as ruvat quite a few times. So that's what we're going to use. And we're going to use it, and we're expected to spot that there are no t values there. So that means it's going to stay put. So can we do a little bit more? Yeah, well, we can. We could say, for example, r equals, and we've got this information. So, it doesn't have to start at the origin always. It starts at 2, 1. And here it just says, write down the position at time t. So we could do something maybe like this. 5 minus 2. And then we just keep the t there to show that it's general. You can sometimes sort of see it written instead like this as well. Okay, so the idea is this is going to tell us where we are as a position vector at any time. So use it to find the time at 4 seconds. Well, we're just going to throw it in there. So at 4 seconds, it's going to be equal to what? Well, it's going to be 2 plus 5 lots of 4. That's the I part, okay? So the I and the j part are separate. I'm writing them as columns because I think it's just easier and a bit quicker, really. So it's going to be this one here. Our final answer then is what? Our final answer is, that's a 22, isn't it? So 22I, and over here, that's a minus 7. So that's the no acceleration situation. What's next? Let's give it a read. So they've been nice enough to tell us it has constant acceleration, but I want you to pretend for a moment that you weren't told this. So imagine that this information was not available. A particle has, well, here's its acceleration. Now notice that its acceleration, this time A, its acceleration doesn't have t in it. Its acceleration is a number, so it has it, and this is the number. It could be written in different ways as well. So, for example, notice that if it were integrated, okay, there would be a plus. There would be a plus c as well. But just for the idea to kind of get into it, you would see t values. Yeah, you'd see t values in the velocity. So that's another way that you might spot it. So constant acceleration. How does constant acceleration tend to go? It tends to go into suvat questions. Okay, so we've got an acceleration in the question. At t equals 0, it's at rest at the origin. Okay, so at rest is giving me that there. At the origin just kind of helps me with s, just makes it slightly easier. So what's the velocity after t seconds? Well, that's when we start using our formulas, yeah? So v equals u plus at, for example. So what are we doing after t seconds? Okay, so v equals, well, that's just like a 0, 0. The acceleration was 3, 2, and times t. Okay, or I could say v equals, well, it's just 3t, 2t here in this case. Okay, hence find the displacement. So the displacement, well, what you might do instead is you might go for one that has s in it. Again, it wants after t seconds, so one with s. and t, and u and a, we tend to have u and a, very common to have those bits of information in these questions. So, we'd write this one down. Ut plus half at squared starts at rest, means that's a 0. It's asking displacement after t seconds. It wants it as a generalized form. Half of 3. Yeah, okay, so half of, what are these values here? So that's a 3 and 2. And then t squared. So I suppose that's equal to 3 over 2 t squared, 1 t squared, or just t squared, for example. Okay, find the speed at 5 seconds. Well, how would we do that? Well, speed means you need the 2 bits, and then you need to find the magnitude. So we'd make the t values 5. What's that? 25 times 3 over 2 is 75 over 2. Okay, and here that's 25. Okay, and then we'd do Pythagoras on those. Okay, magnitude is what we're after when it says speed. So that's sort of a constant acceleration situation. Okay, and finally, what have we got here? So again, it's I and j. Notice I and j can mean many different things. The particle's acceleration is given by this. So acceleration actually has a value there, 6. So it's constant, isn't it, for the I? But look at the j. J's got a t in there, so that means it's quite complicated, really. Now, we could handle them separately, but if we did this together, and for A level, really, this would be a signal because of the t there, because in the changing acceleration, that would mean we had a variable acceleration situation, and this would mean we'd want to do calculus. So integration and differentiation is probably the way to go for this question here. Okay, how else do the questions go then? So you tend to have to integrate up, or maybe integrate up and differentiate down. And then there's some accompanying information here, and this is to help you integrate. So if I sort of show you, if we integrate the acceleration with respect to time, well, that will give us our sort of velocity. More specifically, if we integrate 6, and what's that, minus 2e to the t, with respect to t, what are we going to get? Well, we're going to get a 6t sort of plus a c value. Okay, and for this one here, well, actually that's just the same again, isn't it? Plus its c value, and they can be different c values. So that would now give us the velocity, and the idea is that we're meant to use other information in the question. So when t equals 0, v equals 0. So what do we do with that? Well, we now sort of sub it in to this bit here. So let's sub it in for both. The velocity, it says for I actually, doesn't it? So it's not 0. There's no j part, so that should be a 0. Okay, so 0 equals, t was 0, so what would that be? Well, that's actually just going to be the c1 value for velocity. Okay, for the other one underneath, when t is 0 on e, that makes it into minus 2, doesn't it? So minus 2 plus c2. In other words, although this is good, it's incomplete. Velocity in general would be what? It would be 6t plus 4. Okay, so that's the bit that you get from sort of using a value after you integrate. And then this one underneath is minus 2e to the t plus 2. Okay, so that's how a variable acceleration might go. I will leave the position part to you, but the idea is you would integrate one more time. So mechanics I and j can mean no acceleration. It can mean constant acceleration, which is, suvat really. Or it can mean, if there are t's, if it changes, it means variable acceleration, which tends to mean we go down the calculus route. It's really important that you are able to spot which one you're doing.